Hello again, everyone, and thanks for joining us for another particular live webinar. This is Adam Ralph. Today, I'm joined by my colleague and solution architect, Sean Feldman, who's going to show us how to navigate the vast array of Azure offerings in the messaging space. Just a quick note before we begin. Please use the Q&A feature to ask any questions you may have during today's live webinar, and we'll be sure to address them at the end of the presentation. We'll follow up offline to answer all the questions we won't be able to answer during this live webinar. We're also recording the webinar, and everyone will receive a link to the recording via email. Okay, let's find out which way to turn at the Azure messaging crossroads. Sean, welcome.
Thank you, Adam. Hello, everyone. Welcome to the webinar, Azure Messaging Crossroads. I'm Sean, Azure MVP, working with particular software. And this webinar is all about Azure messaging services. So let's begin. So we'll start with listing, first of all, available Azure messaging services that anyone can start using today if you have access to an Azure subscription. Now, there's quite a few of them. I'm focusing on specifically 4. The first one is storage queues, one of the oldest messaging services. And even though it is not coming specifically from the messaging product group, it's coming from the storage group, it's still considered to be a messaging service. The next one is Service Bus, also veteran of the messaging services in Azure, as well as Event Hubs, followed by the new kid on the block, or relatively new kid on the block, Event Grid. So this session is going to focus on these 4 services, and I hope you will find the information you are looking for. So let's begin. Whenever we're looking at messaging services, the idea is that usually we want, for example, do something such as sending a message. And to send a message, we can use either storage queues or a service bus, for example. Both provide a mechanism called queue that can be utilized to send messages and receive those messages later. So the very first question that anyone encounters is, why would I choose one over another? Why would I use storage queues if there is service bus? Well, maybe, perhaps storage queues is a dead service, and I should never touch it. And rather than using storage queues, I should use service bus, right? One of the questions. Or for example, if we're doing pub sub or publish subscribe, right, and want to publish an event, broadcast an event to multiple subscribers, well, when we're talking about events, service bus is capable of handling events. So is Event Hubs, right? It can ingest events. And so is the new kid on the block, Event Grid. It also handles events. So which one of this is the right service? For example, when Event Grid became generally available, the rumor on the street was that, hey, Service Bus is a dead service. You should not be using Azure Service Bus. Instead, use Event Grid. But that's not necessarily true. Another scenario is when we have services such as Azure Signal R that feel like and seem like messaging services, but they're not, right? And the reason why this specific service is not a messaging service is because it's not durable, meaning that messages are not stored anywhere if the delivery is failing, right? So this kind of service, I do not consider it to be a true messaging service. So with that many options and so many choices to select from, which is the messaging service I should be using in my projects, greenfield or brownfield, right? And how do they fit together in a bigger picture? And do they at all? So the idea of this presentation is to help navigate the services, understand their pros and cons. But I think probably the biggest value is to be able to avoid big mistakes in whatever greenfield or brownfield projects that you're going to have, specifically because you can force these services to achieve what you need. But the question is how much of a pain it's going to cost you and at what cost you will build what you need to build. So with that, we'll start with the first one, storage queues. I also call this service simple queues, right? And the idea behind it is that it's not intended for sophisticated scenario. Now let's look what I mean by sophisticated scenario. So storage queues are task queues. What it means it's designed to coordinate work across compute in Azure. For example, if you have functions or app service or virtual machines that execute work and they want to communicate tasks between themselves and or send instructions, usually messages with intent of something to take place, something to happen. Storage queues intended for that kind of messages. These messages usually contain data, and there is an expectation for that data, something to happen, something specific, also known as commands, right? The sender has an expectation for the receiver to perform something with the data that it's sending, the task to be executed. The service is extremely low cost, meaning that storage queues, number of messages and operations that you're going to consume, comes at a very low cost, which makes it extremely appealing. It's also a very easy to use service. We'll look into the reasons why it's so easy, but there's really not that many features associated with it. So it's both positive and a negative in a way. The number of queues is unlimited, which is very important if you're trying to build a system that requires an unlimited number of queues or a very large number of queues, as well as unlimited number of concurrent clients. And the reason for that is the service is implemented on top of HTTP. So whatever number of HTTP connections that you are capable to establish to the data center, that number of concurrent clients you might have. Now, while the queues are unlimited, the number of messages that can be found within a single queue is limited to a size, not number itself, which is 500 terabytes, and that's huge. Normally, you would strive in your applications and your systems not to store that many messages, especially because these are tasks. They're supposed to be executed, but storage queues, having the word storage in it, is definitely allowing excessively large number of messages to be stored. Now, individual message size is constrained to 64 kilobytes only. And that makes perfect sense considering that these are tasks, right? We're not distributing data. We're not sending anything large objects serialized in those messages. So it's only 64 kilobytes. Limited features, and when I say limited features, those are compute features. What the service is capable to do for us on our behalf on the broker side, on the service side. Okay, and as we move to the next service, you'll see the difference between storage queues and the other services. So what did sacrifice with storage queues? For example, no headers, no metadata. Okay, the payload that is sent in storage queues is the only thing that can be transmitted. There is no headers traditionally associated with messages with other messaging technologies such as RabbitMQ, for example, or MSMQ. It just doesn't exist, meaning that you have to encode it into the payload. There's no features such as publish subscribe or pub sub. Okay, it is only sending messages to a single destination, nothing else. No scheduling features. Okay, it is impossible to send a message in the future or to set a purging option for a message to discard the message once a certain date time has occurred. There's also no dead lettering concept. And the dead lettering concept is basically automated way of discarding messages that are continuously failing processing. Okay, with storage queues, if a message is failing processing, it is responsibility of the system that is attempting to process the message to remove that message off the queue, right? Which means that you have to build those features yourself. No transactional guarantees. But that's not something new to Azure services in general or any cloud services, because transactions, or specifically DTC, is not something that is possible. Though when we're going to talk about the next messaging services, we'll see something interesting there. Now, for production, one of the limitations of this fairly simple service is that we cannot pick more than 32 messages on a queue, meaning that if you have more than 32 messages in production, you won't be able to see anything below top 32 ones. Again, the intent for storage queues is to be tasks that are processed fast. Therefore, you shouldn't be really picking too much into the queues. Now, one of the biggest limitations that was there for storage queues is the retention period, limited to only a week or 7 days. Now, that limitation, about a year or 2 years ago, was removed, and messages can be stored infinitely. But please be careful with that. You never ever want to store messages infinitely. Usually you want something that is meaningful. Otherwise, messaging service turns into a data store or a database. And some other compute-related features that I'm not necessarily going to list here, but when contrasting with other services, we'll mention those. How does it work? Being a simple queue, it works in a fairly simple way. There's a sender and a receiver. The sender sends a message to the service, to the storage queues, and the service is acknowledging that the message is received. The receiver is polling for the messages. It's receiving the messages and confirms whether the message is completed or not. If the message is not acknowledged as completed, the message remains on the broker, the message remains on the server side and available for reprocessing. So this is pretty much storage queues. Let's sum it up real quick. Things to remember: these are task queues, right, for work with items as messages. Very small size messages, mentioned 64K, and if you do some sort of custom envelope to indicate headers or whatnot, even smaller than 64K. It is HTTP based, meaning that no matter what SDK you're using, you can talk to the service from any language using various SDKs that are available. And it's an extremely low cost service, which makes it quite appealing. The next messaging service is Azure Service Bus, also known as Enterprise Service Bus. Now let's look what is the traditional environment where Enterprise Service Bus fits in. For example, e-commerce, right? We can talk about e-commerce where we have front end, where customers can, for example, post their orders. Those orders are not processed on the front end. Usually they processed on the back end, which is scaled differently. And the communication between the front end and the back end is done via queuing or messaging system. Now with Azure Service Bus, it's not just queues. There are 3 types of queue-like entities, and Service Bus calls them entities. So these are queues, topics, and subscriptions. And I'll elaborate on topics and subscriptions in a little bit. So the idea behind this is that we want to scale the front end independently from the back end for processing. For example, on Black Friday, we want to scale the front end substantially, scale it out, but we don't necessarily want to scale up the back end just because we have influx of the orders within 24 hours. The other important thing is that we don't want to lose any of those orders. Okay, this is where we could definitely use storage queues, but there's something more important here, is that we're dealing with money, moving money, for example, or purchase orders, and we want to ensure and guarantee certain transactionality on the messaging level. And yes, I said there's no transactions, but hold on, we'll see something interesting with this specific service. So Service Bus provides advanced features that are not found with storage queues. Some of those features are message headers. You guessed it right. So message headers or metadata about the message. Why is it important? Well, we want to have the headers to allow more complex processing. It's not just a basic task. We want, for example, to indicate what type of serialization was used on the message, right? We might want to add additional data that describes the message or how to process the message, sort of internal instructions for ourselves. Also, headers could be used to manipulate the routing of the message and not just necessarily send it from one point to another. Duplicates detection. If we're going back to the example of the online e-commerce system, there's potentially a chance that someone has submitted the same purchase order more than once, right? So the same message will be arriving identical. And we want to be able to drop the duplicates. So Service Bus, for example, allows message deduplication. The caveat, though, is that deduplication is performed based on the message ID, not on the payload. So the possible workaround is to create a hash from the payload and assign it as a message ID to ensure that identical messages are deduplicated. So that's another advanced feature. Auto forwarding that I mentioned a bit earlier, being able to route messages not just to a single queue, but among different queues, right? Or also known as topology. So Azure Service Bus allows that message routing by using auto forwarding. Deadlining that is built into the Service Bus. And the beauty of this feature is that rather than building your own mechanism to put aside a message that is continuously failing processing, Azure Service Bus does it on our behalf automatically whenever a message is reprocessed multiple times. And the reason why a message could be reprocessed multiple times is either because the message is a poisonous message, malformed message, or because we have some problem in our code and that message continuously failing the processing. Therefore, it potentially could be a poisonous message. Scheduled delivery is extremely powerful. When messages can be scheduled in the future, they will not be delivered immediately, but on the date time, not before, on that date time or slightly later, depending on the queue length, when the scheduled delivery was set. Now, why this feature is so powerful is, for example, whenever you create systems that require some sort of scheduling, for example, doctor's office with appointments, right? And if an appointment is set in 3 weeks, rather than sending a message and the receiver postponing the message for 3 weeks, the receiver will not get anything until the scheduled delivery date is coming up. Message expiration, also powerful feature provided by Azure Service Bus out of the box. And the idea behind this is messages can be purged if they have not been processed by a certain date time. So while the example that I will provide might not necessarily be the best one, but think about stock updates, right? If the stock update is not received within, let's say, 30 seconds or 1 minute, then that message is no longer relevant. Rather than wasting processing power on receiving the message and processing it, it's better be discarded because there's likely to be next message with the next update, right, which should be processed. Message deferral is an interesting feature which helps the receivers that have received the message but not capable of processing it yet postpone the message, put it back on the queue without running into the risk that competing consumers are going to snatch that message and try to reprocess it. So it's almost like being able to set a message aside and say, I will take care of this message when I'm ready on my conditions. And until then, this message is not going to be attempted to be sent to any other receiver. Auto deletion on idle. Another fantastic feature that Service Bus is providing is being able to drop both the messages and the queue that contains those messages if there was no action on the queue for a defined period of time. So for example, if your system is dynamic in its nature and provisions queues dynamically that are used for a short period of time and then no longer required, auto deletion is your friend because it can drop the queue without manually necessarily going to the Azure Service Bus and removing those queues. batching, transactions. These are the features, additional features, but transactions, I want to focus on that one because it is not a transaction that will span your business data or operations to the database, for example, and the messaging operations. We're talking about messaging transactions only. And usually it's coming in the context of the incoming message and the outgoing messages. So for example, let's say we have received a message that requires us to perform certain work. And as a result of that work, we want to announce to the rest of the system that work has been executed or schedule some task or whatnot. We want to have the incoming message and the outgoing messages processed atomically. So either we succeed to complete the incoming message and send out the outgoing, or we revert the outgoing messages and the incoming message becomes again available for reprocessing. So that is a messaging transaction, only available with Azure Service Bus. And then we're also talking about message sessions. If you need ordered or guaranteed order delivery for the messages that you're sending, we're talking about pub sub, which I'll mention a little bit later, being able to decouple between the receivers and the publishers or senders, i.e., you don't, as a publisher, you don't care about who's subscribing to the messages. They will receive it when the message is broadcasted. Filtering and actions, allowing to tweak how the subscriptions are taking place or what the receivers are subscribing to when messages are published. Claim check, while it's not baked into the Azure Service Bus, Azure Service Bus has two tiers, a standard tier and premium tier. Now, standard tier and premium tier have differences, and I'll mention this in a bit, but one of the biggest pain points, for example, is the message size difference that are not matching. So there are options to use something like claim check pattern to overcome these limitations, and some of the SDKs, .NET SDK, Java SDK, I believe Node.js is about to add support for claim check. So all those features, I've spent 5 minutes talking about those, and these are yet not all of them. Those are great. How do we receive messages? Well, there's two options. There's a traditional approach that messages need to be pumped all the time, basically polling for the messages. No different from storage queues, exactly same idea. But there is also a serverless approach that we are not receiving the messages. Messages are pushed to us when we need those, okay? And we'll talk about it later about how we can mix and match. Now, if you happen to use .NET Client, you're in luck, or .NET SDK, because to receive messages, you don't necessarily have to build your own infinite loop, or what we call message pump. You can use helper methods. One of those is called register message handler, where all you need to do is provide a callback to your custom code. And whenever a message is retrieved or received by the SDK, it will be given to your code, and you'll be able to execute the logic. Now, this built-in message pump allows you to fully control the concurrency. So you can specify up to how many messages concurrently you would like to be able to process. The message completion can be either done automatically on our behalf, which is the default, or we can control in the callback wherever to complete message or not. And also lock renewal. And that one is an interesting one because Service Bus, unlike storage queues, does not allow you unlimited message locking. The message is usually released up to no more than 5 minutes. Now, sometimes there's need to go through processing that is longer than 5 minutes. In that case, the lock can be renewed, and the message pump or the message handler provided by the SDK can do it automatically. The one word of caution that I will mention here is you need to be careful with lock renewal because it's not a guaranteed operation. It's not initiated by the broker. It's a client-side initiated operation, meaning that if there's a connectivity issue or some problem, the renewal can fail, meaning that the message will lose its lock and eventually will be available for other competing consumers, right? Consumers that are looking at the same queue to retrieve messages and process those concurrently. All right, and next one is an interesting one. If you're not using .NET, and if you're in Java or using Java SDK, one of the nice features that has been published recently is the first round of support for GMS. And the idea behind this is extremely simple. Without changes to the existing applications, by simply replacing connection string and providing one factory in the connection string builder, you can connect existing GMS-based systems to work with Azure Service Bus. Obviously, there are some limitations, and you should consult with the documentation, but full GMS support is coming. I've mentioned before the premium tier versus standard tier, and I would like to highlight some of the premium features that are kind of important to understand to differentiate from the standard tier. First of all, the ability to control scaling up and down, also known as messaging units. When you provision a premium namespace, instance of Service Bus, you can specify a number of messaging units. It starts with 1 and goes all the way to 8. What you basically locking yourself into, or locking maybe not necessarily a good word, what you promising yourself is specific throughput and latency. And usually based on the number of messages, on the throughput, the load on the system, you will be able to scale up and down. The next one is geo-disaster recovery, or geographic disaster recovery. This is basically what happens if Godzilla decides to visit the data center where your Azure Service Bus namespace is provisioned, right, where your service is running. There's no way the data center is coming back, which means that there will be a failover. So you can have with GeoDR a failover namespace, but there's a caveat. Right now, it only supports metaplane, meaning that only the queues, topics, and subscriptions will be found on the failover namespace, not the messages themselves. Hopefully, the data plane, the messages DR, is going to come this year. Really depends on whatever messaging group can pull this off or not. It's not a simple feature to ask to implement. Availability zones, on the other hand, is by default available for premium tier. And availability zones serves the purpose of high availability, right? So there are 3 replicas of all the messages and all the entities in a given data center, and you are promised to have access to your messages without failing to retrieve those. So don't mix the two. GeoDR, which is disaster recovery, the data center is gone, nuked, versus availability zones within the data center being able to retrieve the data at any point in time. Another feature is virtual network service endpoints, basically making sure that if you have virtual networks in Azure, that none of your messages are traveling on the public network. Metered throttling, again, throttling is also happening on the standard tier more than actually on premium. But since premium tier is dedicated hardware, you can see the utilization, and you can decide for yourself at what point in time, at what utilization point you will be scaling up, or if you need to scale down. But throttling will occur if there is excessive utilization of CPU and memory, which Azure Monitor should help with. Now, what happens if you're using standard tier and thinking of migrating, for example, your production to premium tier? Well, good news is that there's no downtime. You literally can migrate on the fly from the standard to premium tier. You will be using same connection string for the senders and receivers as before. You don't have to stop those endpoints. You don't have to stop your services. They will continue functioning. You will have to have an additional, obviously, premium namespace provision before you start the migration process. Some messages might need to be drained, and that's because at the cutover point in time, there will be certain messages. If the senders continuously send messages, there will be some messages that won't make it over. You will basically need to drain them manually and move to the other namespace. And it only supports up to 1,000 entities. Now the question is what to do if your namespace contains more than 1,000 entities. My personal recommendation is to open support case with Microsoft and work with their engineering team, because they will be able to assist you. There's nothing that you will be able to do on your own unless you reduce number of entities and stay within the limit of 1,000. Now the migration can be done on the portal, fairly straightforward. As you can see, 3 simple steps. Now UI might have changed since it was announced. Now let's sum it up. What is Azure Service Bus? So the things to remember are queues and topics, right? So it's not just simple messages that we send into a single destination. We can also broadcast. Rich computer-based features, many of those, and I encourage to read the documentation and review those features to understand fully Azure Service Bus and how to take advantage of what it provides. It is the only service that has transactionality or transactional support on the messaging level. Storage queues doesn't do that. Neither do other services that we'll cover in a bit. It's extremely reliable, allows to implement complex workflows thanks to auto forwarding, metadata, and other features that exist. And with that, we'll switch to the next messaging service, which is Event Hubs. Now, Event Hubs is substantially different from storage queues and Service Bus. And why is that? Well, I'll use the analogy of a tape. First of all, Service Bus, while it receives messages, it doesn't handle messages. It handles those as streams of messages. The recording that happens of those messages is always moving forward, just like the tape. Okay? You can play a stream over and over again, so you can basically retrieve same messages again and again, right? Similar to cassette, it has channels. Cassette has 2 channels, right? Left and right. Event Hubs has a little bit more. We'll talk about this. The data on each channel is different, so it's not the same messages. And these channels, rather than calling them channels, we'll call them partitions. So let's have a look at somewhat internals of the Azure Event Hub. As a service, it has partitions, right? We agreed upon that. And those partitions record different messages. Those are streams of the messages, usually provided by event producers that can communicate to Event Hub using one of the following protocols: HTTP, MQP, or Kafka. Yes, Kafka, even though it's not an Azure service. We'll talk about that a little bit in a few minutes. And then on the other side, there are event receivers that are not receiving single events, right? Individual events. They read those through consumer groups, and they read the streams. Those, and I'd like to point out the inverse direction of the consumption. It is not a message going to the receiver, it's receivers picking up those messages, and I'll elaborate on this emphasis a little bit later when we talk about additional aspects of Event Hub. And we can have obviously multiple receivers with their consumer groups that are reading messages from all the partitions. So does this sound familiar? Yes, and I've already mentioned it can consume from Kafka, events from Kafka. Are they 2 similar services? Yes, in a way. Both are ingesting technologies. They're not queues. It's an important differentiator. If we were talking about storage queues, that was a queuing service. When we talked about Azure Service Bus, that was a messaging, but still a queuing service in a way. Event Hubs is an ingester. It's not a queue. Now, both Event Hubs and Kafka use partition consumers, and those partitions are independent. And the important concept that I wanted to point out is that the client is managing the cursor and not the other way around. In other words, it's the consumers, the clients, that need to remember the location of the last message in the stream that they have processed or read, as opposed to storage queues or Azure Service Bus, where those services remember what the message that needs to be given to the client when the client is asking for the next message. And back to event hubs, just like Kafka, can scale to very high workload, and also conceptually nearly the same, right? Both are ingesters, which means that every Kafka user is close to being an event hubs user if they decide so. As a matter of fact, Kafka 1.0, there's full compatibility between event hubs and Kafka. You can, if your system is on Kafka today, you could switch connection stream to event hubs and start using event hubs. The existing Kafka applications and tools will be working with event hubs. Just the connection string is the only difference. Now, let's talk about a little bit about scaling, because while it's an ingester and it's capable of processing large amounts of events coming in, there is a certain throughput units that you can utilize. Again, there is standard and there is premium tier. On premium tier, we're talking about throughput units, very similar concept to the messaging units in Azure Service Bus. Now, the capacity that you can reserve for throughput units is only on the premium tier, or Event Hubs calling it dedicated tier. A single throughput unit is about 1 megabyte per second of ingress ingesting, or about 1,000 events per second. Egress is twice of that. And if it's not enough, you can go up with throughput units, and you can scale to substantially a very large amount of messages, both ingress and egress. Now, overages are throttled. An exception will be thrown, but to handle that, there is a feature, specifically designed feature, called auto-inflation. Now, this is not auto-scaling, and it's called auto-inflation on a purpose, because with insufficient throughput units, senders will be throttled, right? With the auto-inflation turned on, the throughput units will be increased up to a defined cap, which you have to define yourself. But those throughput units will never be scaled down if the ingress is falling down, for example, right? That's why it's auto-inflation and not auto-scaling. The other thing to remember about event hubs is retention period by default, which is 7 days, right? And again, an additional feature specifically designed to handle this issue called Event Hubs Capture that allows you to tweak this retention period, but not exactly the way that you would think, oh, I can keep it for a longer period of time. Rather, automatically send those events or Event Hub data into either storage account that you will provision or Azure Data Lake. And what's nice about this is that it allows you to minimize the overhead associated with the downstream that is required to process the data. So for example, if you're auto-inflating and receiving a boatload of events, right? Rather than scaling up or scaling out your processing at the same time, you can redirect the data, those events, to be stored in storage account and process on your own terms and conditions, which is very handy. So you're focusing on processing and not so much on the capturing. So how the capture works, with the Event Hub, right, and the partitions that have the data, we define a capture rule for data storage account, for a storage account. We usually need a container to be defined, re-provisioned, and 2 parameters, size and the time. So for example, in my case, I'm going to specify that size is no more than 100 megabytes for an output file or blob, and time should not exceed more than 10 minutes. So whatever comes first will generate a blob, and those blobs are automatically generated as the data streamed into Azure Event Hubs. The formatting is storage account and the container that we provide, and after that, it's the namespace with the Event Hub name, the partition, the date timestamp, and the format is well-known Kafka format.avro. Now, what happens if you're using .NET helpers again? If you're using .NET SDK, there is a safe batching support, for example, which means that you can send events without worrying that you will exceed maximum number of events that could be batched together, which is very convenient. You build up the batch knowing upfront that whatever you sent is going to be successful, unless obviously there is a communication failure. And the consumption of events and managing the cursor on the client side can be simplified by Event Hub client and Event Processor host. So those two are basically an abstraction on top of storage account with a blob, and it can manage the cursor for you. You don't have to write your own logic. So let's sum it up. The important things about Event Hubs. Remember, throughput over features, okay? We haven't seen that many features. I've highlighted two of them, auto inflation and storing data rather than trying to process it real time. Again, this is because the purpose of Event Hubs is not the same as queuing or general messaging service. It is ingesting, right? Not a queue replacement. Important to realize that. And you have to manage cursor yourself or use a helper library or SDK ways that provide management for you. It is not something that service is going to do for you. And with that, the next and the last service, Event Grid, or the new kid on the block. And let's understand, why did we need all this? I mean, we've seen storage queue, service bus, and Event Grid. A combination of those three could potentially, give us probably everything we needed. So why Event Grid? Well, the traditional events receiving is usually based on the fact that there is something happening, right? Some sort of event occurred, and that event needs to be communicated to a system for processing. And the reliable way of doing so would be a queue. And we would have a process that would execute 24/7, that would retrieve that message, right, that event, and process. The only challenge is that the processing part, the right side of the screen, would have to be running 24/7, right, polling continuously for the queues, receiving those messages. If we're talking about storage queues, we would have to poll. If we're talking about service bus, we would have to run our process 24/7, polling the events, even at the situations when there are no events happening at all. Now, an event is a lightweight notification of a condition or a state change, okay? I'm gonna highlight the lightweight notification. So something very simple that happened might come out to us or might not, depending if the event happened or not. And there is a theme that we have seen in the recent years that more and more systems prefer to do the pub sub model, right? When we want to be subscribing to the events, to be notified when those are happening rather than retrieving those. We want to build reactive systems and reactive applications, right? When we only have to respond to an event that happened as opposed to continuously running. And the architecture as a whole to be event driven. There is also a conflict of push versus pull. With all the services that we've seen so far, messaging services, it was based on the pulling model, not the push model. But the push model is much easier to comprehend and sometimes makes much more sense in a reactive world. So for example, a few scenarios that we can think about is serverless applications, right? Let's say I've got a storage account, and that storage account, I'm using cognitive services to process images, right? If there are no new images uploaded to the storage account, I don't want to run 24/7 and check, are there any blobs? Are there any new blobs? Are there any new blobs? No, I'm only interested to do processing, to do the work when blobs, new blobs are detected. Another example is operations automation, right? When we provision new resources, we want to categorize those, or we want to kick off some process, for example. Again, it's very reactive in its nature, right? Something has to happen. The resource has to be created. Only then we will execute the work. And not to mention the fact that we might want to do some third-party integration, right? When we want just to announce that we have an event, but we don't want to control who's subscribing at what point or how many subscribers are there. We don't want to think about that aspect. All we want is to broadcast to the world and the world to handle whatever we have. So scenarios such as these ones have triggered a thought about, okay, the existing services, messaging services, are not quite the services to fulfill this role. This is where Event Grid is coming in. And Event Grid is the man in the middle, if you wish. It connects between the systems or the services that have events to publicize, and on the left side, and on the right side, event handlers that will be processing those. Now, this is just an example. We'll go into details, but you will see a lot of Azure services on the left side, except the last two items, CloudEvents and custom events. CloudEvents are cross-cloud events, so those do not have to be coming from Azure services or Azure at all. And custom events are events that you can emit yourself, right? Come up with whatever events that make sense when you want to perform an integration or notifications. Now, on the handling side, on the right side, we have several categories of who handlers can be. So for example, it can be serverless code with the functions, right? An example, a canonical example, I'm putting something, I'm creating a blob and storage blob, and a function is automatically triggered, right? Or same thing could be done with the serverless workflows and integrations with Logic App. Or we can leverage other messaging services, such as Service Bus, Event Hubs, or storage queues, to do the later processing, leveraging Event Grid. So Event Grid can actually submit or send those messages to the other messaging services. And other applications and services, including the simplest thing, webhooks. So anything that can execute webhook can become a subscriber to Event Grid. Okay. Now, Event Grid is fairly new service. There are continuously additions that are coming. For example, Key Vault was added recently, machine learning emits now events as well, and Azure Signal R. And in the preview, as of recently, Azure App Service, the web apps, and the Redis, the Azure Redis cache. Now, why don't we see all of the services emitting, Azure services emitting those events? It's very, very simple. Microsoft is taking a very conservative approach that customers should know what events they're interested in. So rather than building and hoping that everyone will come to use those, customers should be letting know Microsoft what are the events that they're interested in, what are the use cases, and if there's enough merit, they are building those events. So if you're interested in Azure Event Grid events, let Microsoft know. So let me briefly go over some of the concepts of the Event Grid. Some of them we've seen. The event is what is happening, right? What are we notifying about? Event source is where it's taking place. It is important because if it's Azure service, there's less work to do. But if, for example, it's a custom topic, then there's a little bit of more work that needs to be done because we need to provide a topic, create a custom topic where those messages will be published. Event subscription. Subscription is the intent to receive messages with a criteria. So for example, I'm interested in all the blobs, or I'm only interested in the blobs that have a JPEG extension and whatnot. And then event handlers, these are specific application of the services that will be reacting to those events that subscriptions are catching. Now let's have a look at an example of an Event Grid message or Event Grid event. Okay, while it's JSON and JSON is schemaless, there is a certain structure. For example, there's topic, subject, and event type. Event type is extremely important because it uniquely identifies the type of event that is coming in to allow processing. The other mandatory block is data block, which is, well, all the data required to be able to process that event. But be aware, in this case, we have an event called blob created. So in storage blob under a container, the blob was created. It is not the blob data that is coming here, it's the metadata. Because remember, event is a lightweight notification, should be enough for the subscribers, for the receivers, to identify whether they want to process or not. So in this case, content length of that blob is what, 500 something bytes. And we have also the URL, which indicates where the blob actual data can be found for processing if needs to be. A message size is 64 kilobytes, used to be. Now it can go up to 1 megabyte, but keep in mind that the charge is happening based on number of 64K chunks, okay? So don't go too crazy with it. You're not gonna save money if you packing it into a single message. Now about filtering, I'm not gonna go into the filtering in details because documentation is there that can explain it all, but you can pretty much filter on any property within the schema that we've seen, including the values in the data. And there are permutations of different functions and possibilities. Now, event domains is an interesting feature with Event Grid, which simplifies publishing. And probably the question is, why do I need to simplify publishing of the events? It's fairly straightforward. What happens if we have multiple subscribers, but not all of those subscribers should be able to receive one or the other type of message? Well, in that case, rather than creating multiple topics or topic per customer, there could be a single topic with event domain endpoint, which can control, using Azure Active Directory, which customers can retrieve what message types. So from the publisher perspective, the work is simplified because the publisher just emits the messages to a single topic, and Azure Active Directory is ensuring that only those that can access specific message types will be seeing those, and they will not receive the message types that they're not supposed to. Now, we talked about topics, subscriptions, filters. You know, we've seen it all, right? We've seen it at least with Azure Service Bus. So then why Event Grid? Why is it so different? Well, it's cloud native by design. Unlike other services, for example, Service Bus, which was designed around, what, 8-9 years ago, went into production. Event Grid was designed recently with cloud in mind, with the scale that is required. It is serverless friendly. It's very easy to start using Event Grid. And if you have played with Azure Functions, for example, you have seen that wiring a blob storage with an Azure function using Event Grid is extremely simple. It is engineered for reliability and scale in mind. So it's not, the messages are not failing if the receiver is not available. I'll talk about it in a little bit. And it's embraced support for CNCF or Cloud Native Foundation, sorry, I forgot the name, but basically standardized format for events. And we'll look into that in a second. So Cloud Native by design, availability for 9's SLA, near real-time event delivery. So it's less than 1 second end-to-end, at least once delivery. Dynamic scale. You don't have to worry about provisioning anything. It's all handled by the server. You don't have throughput units. You don't have messaging units, none of that. Internally, servers can handle tens of millions of events per second per region, or hundreds of millions of subscriptions per region. We don't do anything about that. It is platform agnostic because it's technically based on a webhook, right? Anything that can receive a webhook can handle event grids. Events. And it is language agnostic. because the transport is HTTP protocol based. Now, when I'm talking about scale and reliability, by default, there are 30 delivery attempts within a time frame of 24 hours. If the messages are failing, there are retries, and this is the default scheme for those retries. They can be reconfigured and redefined if you want less number of delivery attempts or lower the time. There's also a possibility for dead lettering. It doesn't require storage account and a container to be provisioned. And every message that is failing delivery after retries is stored as a blob, as an individual blob. The downside of this feature currently is that if you want to retry any messages, unlike storage queues and unlike event Azure Service Bus, you cannot just resend the message back to the destination. In this case, that would be republishing the blob to the topic. You actually have to convert the blob, contents of the blob, and publish it again as a message. Hopefully, Microsoft will patch this hole and address this issue. But messages are not lost. That's the important thing. Now, when we're talking about Event Grid and CNCF Cloud Events, what it does, it opens up the possibilities, not just leveraging Azure, but also other clouds. Because CloudEvent is an open format and agreed upon all the vendors, major vendors at least, you could be publishing from GCP your events or from Azure and consuming those either in Azure Functions or AWS Lambda. So the interop between various cloud providers is becoming a much better story, right? What that CloudEvent schema looks like, very similar to what Event Grid event schema looks like. Ignore the little typo for the event version. It's 1.0, not 0.1. And you will see the same pattern, right? There is an event type, which is specifically identifies the type of the event so that we could handle it. And there is a data block, which provides the metadata that is required. So this is exactly the same event that we've seen with storage blob, just expressed as CloudEvent. And Azure services can handle it, or you can handle it on any other cloud. So it is ubiquitous. Today, we've seen 10 plus Azure publishers. Hopefully, at some point in time, most of the Azure services will have the publishers. But again, you have to remember, if you want something, you have to ask for it and explain why. It is serverless friendly, as I've mentioned before. So for example, if you go to any service that supports Event Grid already, you will find in the menu the events section, which allows you to wire that service instance with whatever the subscribers for processing the events that the service will be publishing. You can also achieve that using PowerShell or Azure CLI, whatever is more convenient. So events and streams, that's an interesting one. And I've mentioned before that the Event Grid topics can actually have subscribers that are other messaging services, such as storage queues, Service Bus, or Event Hubs. And the reason for that is that these messaging services can be publishers or subscribers. And the nice thing about it is that we can level the load associated with Event Grid, because Event Grid can be pretty much floodgates that are opened, and our system would not necessarily be able to cope with that amount of events that are received. This is where the combination of the services is very helpful. Now, when it comes to security, there's a validation handshake for the subscribers to ensure that no one has subscribed accidentally or they did not intend to receive those events. What happens is the event of a very specific type, subscription validation event, and it's in its payload, it contains the validation code that has to be sent back to a very specific URL. Basically prove of the intent to subscribe. You need to echo back that validation code. All right, so let's sum it up. Event Grid, what's important? Event-driven systems, right? Whenever we want to deal with the events, massive scale, that's Event Grid. the pub sub, right? Yes, we have pub sub with service bus, but when we want to make it more scalable, cross-cloud, inter-services, Event Grid is a better candidate. It is not enterprise messaging replacement, and it's important to remember that. High scale, high throughput, retries baked in. Okay, so there is reliability. Messages are never lost if they cannot be delivered. They can be dead lettered into storage account. And support for cloud events with the open format agreed upon multiple cloud vendors, which makes it cross-cloud, a good candidate for cross-cloud. So let's summarize everything we've seen so far for these services. It's great. I've highlighted, a lot of cons, some of the pros of these services, but how do we really choose the right Azure messaging service? Well, it would be extremely simple if I would give you a diagram, right, that you would just follow the arrows with simple yes and no and get to the service that you need to use on your project or multiple projects. Unfortunately, the reality is way more complicated and sophisticated. But still, I hope that from this webinar, you have learned a few things, such as, for example, when you're working with serverless, most likely that you will evaluate storage queues and event grid because of the nature or the requirements for serverless implementations. If you're dealing with big data, no-brainer that event hubs should probably be the first one to evaluate. And also, if you're using another service, let's say storage queues, and you have to deal with big data, don't try to overload storage queues with the responsibility of, ingester, because that's what Event Hubs is designed for. Now, if you're building enterprise systems, workflows, dealing with money, every single message counts and important, it's not telemetry, then most likely you're going to be evaluating Azure Service Bus, especially if the system is an organization-specific system. It doesn't have to interact with anything external. But at the end of the day, you have to remember that it's the right tools for the right job. It's not a single tool. It's a combination. And an example could be the traditional system that we looked at, right, with the backend that is continuously pulling messages from the queues to process those. It might not necessarily be the same solution in the future. For example, let's say we have messages that are coming in, but not a continuous flow of those messages. They are sporadic, right? Sometimes we can have tens of messages or thousands of messages per second, and sometimes we could sit idle for a few hours. Rather than having on the right side backend processing 24/7, we could have messages sent to a queue, storage queues or Azure Service Bus queues specifically in my example, and combine it with an event grid. An event grid can work with Azure Service Bus, and it has an event called active messages available with no listeners. So that event, we could subscribe in our system to that event. Upon receival of this event, we would kick off the processing of the messages until we are done, no more messages to process, and could shut down our processing. And this is the idea what serverless in a way implements for us, because, for example, our AWS Lambdas or Azure functions are not running 24/7. They only run there for the period of time that is necessary. But it doesn't have to be Azure functions or AWS Lambda to take advantage of this pattern, right? We can combine, in this case, Event Grid and Azure Service Bus to benefit. So with that, I would like to thank you and switch to the questions.
Thanks very much, Sean. So yes, as we mentioned, we've got a bit of time for some Q&A now. So I'm going to pick out a couple of questions, and apologies in advance if I pronounce anyone's name incorrectly. But Mark Tiling has asked an interesting question, and Mark says, does scheduled delivery of the messages in Azure Service Bus always deliver the message on the end of the queue? And if so, isn't it better to use another system or queue to handle this?
That's a good question. Indeed, what will happen is the message will show up at the end of the queue. It really depends whether the queue is busy or not. If the queue has hundreds of thousands of messages sitting in front of that scheduled message, it will have to wait for the processing of the other messages. The idea is to be able to scale out for message processing, not to be in that situation. Now, wherever it would be more meaningful to use another system, another queue, potentially yes, but it really depends on the scenario. Sometimes customers prefer to store something that is scheduled in the database, but then you have to have periodic, querying of the data and seeing what's up for grabs or what needs to be executed. Sometimes it's much easier to just schedule a message. If we're talking about the real-time systems, for example, when a message has to be scheduled at a specific point in time and has to be processed exactly at that time, probably this feature is not relevant. But for general use, when you want to schedule something as a reminder, for example, and ensure that it takes place, but just not before the daytime, then this feature is fine.
Okay, thanks, Sean. And another good question has come in from Adelino Rodriguez, and this was actually sent in ahead of time by email. And Adelino asks, we're intensively using messaging in my organization, but in an on-premises fashion, using JMS and applications deployed on an Oracle WebLogic server. I'd be interested in finding out whether Azure offers options for message handling in a transactional way. For example, in the case of an error when saving to a database, rolling back the transaction would also roll back the message to its starting point.
Yeah, it's not an easy question. So first of all, JMS support, I mentioned that it's already in place, not 100% completed, but they're getting there. In terms of transactional processing, that would cover both the messages and other operations. It is not possible. I mean, DTC does not execute well in any environment that is a large environment, let alone cloud environment. What would need to happen is probably, but sorry, I will step back. With Azure Service Bus, transactional message processing is possible, is doable. So incoming message in the transactional context with the outgoing messages. Now, what happens is that the operations, such as writing to a database, would need to be performed before the messaging transaction is completed. So in essence, we can create code that will guarantee that incoming messages will not be completed and outgoing messages will not be dispatched if the database write was not successful. So that is possible. And it's possible with Azure Service Bus because of its native support for a feature called Send Via, which in essence support messaging transaction.
Okay, thanks, Sean. So there are some more questions outstanding, but as I promised, we will follow up with those offline. Before I wrap up, I'd just like to mention that our colleagues will be speaking later this month at the Segfault University in Warsaw, Poland, and Sean will be speaking at Prairie DevCon in Calgary. So if you can get yourself over there, then you'll get to meet Sean in person. You'll also see us at NDC Minnesota in September, and shortly after at Explore DDD in Keystone, Colorado. You can also go to particular.net/events and find us at a conference near you. That's all we have time for today. On behalf of Sean Feldman, this is Adam Ralph saying goodbye for now, and see you at the next Particular live webinar. Thank you.